So we're asked to write a limit statement. Okay? So there's two parts to a limit statement. There's a limit as x approaches negative infinity, right, on the left side of our graph. And there is a limit as x approaches positive infinity. So we need to figure out what our graph is doing to the far left and what is our graph doing to the far right. Okay, so these are your limit statements. Anytime you're asked to write a limit statement, this is the x decreasing without bound side, and this is the x increasing without bound side. Right? We have two sides to our graph, the left side and the right side. So this is the left side of your graph, and this is the right side of your graph. Okay, we have a rational function. So there are three options. We have top heavy, bottom heavy, or neutrally heavy. This one happens to be a top heavy rational equation. Right? We have an x cubed on the top and an x squared on the bottom. Okay, top heavy equations have no horizontal asymptotes, but they do have a slant asymptote. Okay, so we're going to spend the rest of this video talking about how we find the slant asymptote, and we do that by using long division. Okay, long division. So in long division, you put your denominator, which is x squared plus 2x minus 5, on the outside of your division bar. Okay, and on the inside goes your numerator. But notice we are missing a term. We have an x cubed term and we have an x term. That means we're missing an x squared term. So in order to have all of our terms, we represent that with a 0 x squareds. Our equation has 0 x squareds in it. It's important because you're going to have to do some subtraction later. Minus 4x plus 1. Okay, so here is something you need to remember. You need to have every single power from the highest all the way down to the nothingest. So now we have to think in our brains, what do I multiply x squared by in order to make it into a 2x cubed? Okay, so that means I have to multiply by 2x, right? Not just 1x. If I multiply this by 1x, I just get x cubed. I need to have the coefficient also. So I have to multiply the 1 by a 2 in order to get my 2x cubed. Okay, and just to keep it in order, I put my 2x above my 4x in my x column. So all of my x's will be in the same column. Okay, that's just preference. So now we have to distribute. You multiply the 2x by all of these terms out here. Okay, that gives me a 2x cubed and a plus 4x squared and a minus 10x when I multiply each of these terms by 2x. Okay, now my algorithm says I need to subtract that whole entire yellow equation from my white equation up above. Okay, so that's a minus 2x. I'm going to change this sign to be a minus 4x squared, and the minus changes to a plus. Okay, so subtraction means we change the signs. So 2x cubed minus 2x cubed, right? That's your 0. That's exactly what we want. And here is why we put in our 0x squared. Because without it, we don't have any like terms to subtract from my minus 4x squared. Okay, so it's important to have that in there to have a minus 4x squared. 0 minus 4 is minus 4. Negative 4 plus 10 is plus 6x, and then we drop down the plus 1. Okay, so make sure that we have every term has something to add or subtract to, which is why it's important to throw in this 0x squared so that we have something to combine with our 4x squared. Okay, so now we go back and think, what do I multiply x squared by in order to make it into a minus 4x squared? Right, I'm only concerned about the first term going to my first term. That's all I'm concerned about. So I need to multiply this by -4. Okay? And for our purposes, we can stop right here. This is going to be the equation of your slant asymptote. Okay? We don't have to distribute the -4 and go all the way and figure out what the remainder is. All we want is the equation of our slant asymptote. Okay? So let's come back down here then. We have y equals positive 2x minus 4. Okay? So now let's think about, now that we have our slant asymptote, what are the infinities of our slant asymptote? Well, because we have a positive slope, we know that that grows from left to right. Our function is always increasing from left to right. Okay? So if I were to put some axes on here, I don't know where the axes are going to go, but we'll just put them right there. To the left side of my graph, my y values are at -infinity. Okay? So that means the limit as x decreases without bound is -infinity. And then on the right side of my graph, the arrow points up, so it will continue on to positive infinity. Okay, so in order for me to write the limit statement of a rational function, I need to know about its heaviness. Okay, if it were bottom heavy, then these are always 0. Right? Those are your horizontal asymptotes. If it were a neutrally heavy, then we're looking at the y values from your coefficients. Right? And it's the same on the left and on the right. The only time it's different is if we have a top-heavy function and we have to find our slant asymptote equation. So positive slopes grow from left to right, and of course negative slopes would have the opposite if we had a negatively sloped slant asymptote. Okay? Hope that helps with writing limit statements.